Okay, welcome everybody. You probably got the idea by just looking at what you see on your screen that we'll be dealing with light today. We've been dealing with light, and we're going to deal with a little bit of reflection. Now I've got a mirror set up right over here, and I've got a pretty powerful laser pointing at that mirror. If I take that laser and slide it around, you can see how that beam behaves, how that reflected beam is bending relative to that incident beam. And a lot of people say, well, it's coming off at the same angle. And you would be absolutely right that it's coming off at the same angle. What we need to be able to do is we need to be able to make sure that you guys know how to be able to draw this, measure it out, and accurately describe what happens with reflection. So I'm going to ask you guys to do the following. Get out a piece of paper, and I'm going to turn my paper so it's going to be, now I'm going to keep it upright just like this. I'm going to keep it in portrait. And I'm going to draw a line right across the top of the paper here. There we go. Now I'm going to leave myself enough room so that if I have a protractor, and I'm going to actually back the camera out a little bit just so you can get a better idea of what's going on. There we go. That's better. A little bit more. That's pretty cool. All right, perfect. So you want to make sure you got enough room above that you can fit half the protractor when you do this. And first thing we'll do is we're going to draw a nice horizontal line, leaving enough room above the top. And I'm going to ask you guys to please do exactly that. Get a pencil. You really want to do this stuff in pencil. And draw a nice horizontal line going across. And make sure you got enough room. I'm not even sure I left myself enough room. I didn't. So let me take another shot at this. Flip over. Make sure I've left myself enough room that I can get that protractor fully across. Let's take another shot. I'm good now. I'm good. All right, so I'm going to ask everybody to make a little mark in the middle of your paper. And once you've made that little mark in the middle of your paper, lay down your protractor. And we're going to draw a light beam going in. I want you guys to measure this. And I want you to mark this right now at the 30-degree mark. And draw a line going into that point. Now we call that our incident ray. So let me label that. And I should mention that I'm going to ask you guys to send me a picture that you actually did these notes out. Okay, part of the homework's going to be to do that, is to just have these notes set. Now, there's our incident ray. Now, you probably say, okay, I can just measure on the other side and draw my reflected ray. However, we never, ever measure from the surface when it comes to light rays. Particularly when we start dealing with refraction, it makes everything completely wrong. So what we're going to do is we're going to take our protractor. We're going to lay it down so that my center, that center line is on my horizontal line. 90 degrees is right on there. We're going to slide it over so the edge of the paper, edge of this protractor, forgive me, is right on that point. And we're going to draw a dotted line perpendicular to the surface. This is called the normal line. A normal is a line perpendicular to the surface. It's an imaginary line. And it's perpendicular to the surface. Okay. Now, we always always, always, I'm going to put this down here. We always measure our angles relative to the normal. In other words, we are not going to measure this as a 30 degree angle, because that's what we measured over here. This guy was 30 degrees. We don't care about that. We want to measure here. We want to measure from the normal. Always, always, always from the normal. Notice that I've got 0 right here where the line meets. I've got over here right along the normal, my 0 degree line. Everything looks good. And if I measure this out, that's going to give me an angle of 60 degrees. This is called my incident angle. And theta I is going to be 60 degrees. That's what we care about. This is what's important. That is junk. I mean, you can use it to figure this out, but you don't need that. As you saw from the demo in the beginning, the light is going to reflect off this mirror, which I should have labeled that right in the beginning. Okay? It's going to reflect off at exactly the same angle. So if I take this, I rotate it over to 90 degrees. It's on the surface, 0's on my normal, and make a mark at 60 degrees on the other side. And draw my light ray. This is my reflected angle. Okay, and this is, reflected ray, forgive me. Let's get rid of that. And up here is my reflected angle. And you saw before, it's going to be the same thing as my incident angle. And that's basic, or this is also referred to as specular reflection. Okay, and of course you've seen it plenty of times before. Now let's try something a little bit different. Right now I'm going to disconnect the camera from my from the mounting here. I turn on the laser, and I've got the laser pointing at something that's pretty dark right now. It's going to be pointing over here, just at like a black felt that's inside my phone holder. And we're going to point the camera now up at the ceiling. And I've got that laser pointed right now at that black paper. And let me take this and turn it around so you guys can see. Whoops, we're upside down here. Right now. And then I'm going to take it, I'm going to move it from here over to the white paper. And I want you to look at the ceiling. At the black, I'm on the white. On the black, onto the white. And you can see there's actually a shadow cast there, but the light is kind of all over the place. It's not like I'm shining a beam in the air like that. Well, what's actually happening here? Why is the light getting scrambled and thrown all over the place? Well, the reason for that is because of the surface that I'm shooting this at. Let me take a look at it here. Cool. Let's shut this down. When I take a look at a piece of paper through a magnifying glass, a piece of paper really looks very, very rough, okay? I'm leaving a little room up here on the top. Let's say I've got a rough surface. And I shine into this light. These are all parallel rays of light. Well, at each point where these light rays hit, there'll be a normal. This normal, perpendicular to the surface, might go like that. This normal might be like this. That normal might be like that. And this normal might be like that. Notice the normals are all over the place. Well, the light is going to wind up getting reflected all over the place. For each point where it hits, the angle of incidence is going to equal the angle of reflection. Okay? Which is the rule for reflection. However, it's getting scattered all over the place. This is called diffused reflection. Going back up to the top here, and I should have added this little thing in before, the basic rule for reflection is the angle of incidence equals the angle of reflection. And it's actually in your reference table. Theta I equals theta R. And that's it for today. I know you guys have APs this week. I'm not going to overload you with a ton of stuff. I'm going to keep it really, really simple. You should be able to get through the whole lesson probably in 20 minutes or so, and probably, maybe about, well, this is about 12 minutes, and probably maybe about another 15 or so to do the homeworks. All right? Take care. All right. See you guys later. Bye-bye.